I will be speaking on functioning of MBBR technology sewage treatment plant. Here is a 3D model which I want to show you. The STP comprises of multiple chambers which covers the collection of sewage in receiving chamber, then sewage goes to stilling chamber and subsequently to equalization tank, covered anoxic tank, MBBR tank 1, MBBR tank 2, filter press unit, multi-grade charcoal filter, and finally to the covered treated water tank. Subsequently, I will be briefing on the specification and the purpose of each tank. Here is a block diagram which gives a more descriptive view of the STP and the stages involved. Stage 1, course screening. The course screening will be placed at this location. This shall be the inlet point of the sewage and will be screened through course bar screen in order to remove floating material. Then the collection sump. Collection sump is the same receiving chamber. The sewage will be collected in the sump below ground and will facilitate the raw sewage transfer pump. Stage 3 is the pumping. The pumping from receiving chamber to the stilling chamber. To transfer the sewage from collection sump to the equalization tank, raw sewage submersible pump. First, the raw sewage comes to the receiving chamber. That's the stage 1. There's a course screening placed in the receiving chamber. This shall be the inlet point of sewage and will be screened through course bar screen in order to remove floating material. Then comes to the stage 2, collection sump. The receiving chamber itself is the collection sump. The sewage will be collected in the sump below ground and will facilitate the raw sewage transfer pump. The stage 3. Stage 3 is the pumping of the sewage from receiving chamber to the stilling chamber. To transfer the sewage from collection sump to the equalization tank, raw sewage submersible pump are to be provided to meet the peak flow condition. Then the stage 4 is the stilling. Stilling is done to reduce the velocity and for maintain the laminar flow. Sewage is received in the stilling chamber. Then stage 5. The sewage goes from stilling chamber through fine screen to the oil and grease chamber. The stage 5 is fine screening. Sewage is screened through bar screen in order to remove fine floating material and solid particles, etc. The stage 6 is oil and grease removal. In order to remove the oil and grease present in sewage is to be removed before it enters in process, as it make a layer on the MBBR media which restrict the development of bacteria. Then the sewage goes from oil and grease removal to equalization tank. The sewage is generated in erratic pattern throughout the day. In morning and evening it is higher than average, and in noon it is lower and even zero discharge. Also in late night, to equalize the irregular flow of sewage, collection tank is provided so that average flow can be pumped to the process reactors to achieve desired results round the clock. Aeration is provided in the tank to avoid any settling of solids and to maintain homogeneous condition in the tank. For the purpose, UPVC air grid having coarse holes is placed at the bottom of the tank and air from common blower is provided. Then stage 7 is pumping. The sewage is pumped through self-priming centrifugal monoblock pump at the average flow to the anoxic chamber. Then the stage 9, anoxic chamber. An anoxic zone is created by using an unaerated tank where the dissolved oxygen level are kept below 1 mg per liter and as close to without reaching 0 mg per liter as possible. A target operating point would be between 0.2 to 0.5 mg per liter. Then stage 10, biological decomposition tank, that is MBBR tank, moving bed bioreactor. The sewage decomposes the biological impurities with help of aerobic bacterial culture on spatial media in presence of air in the MBBR reactor. Two numbers provided in series. The required air will be provided with help of air blower, cause bubble, air diffusion grid. Then comes the stage 11, aeration. Stainless steel cause bubble air grid will be used in process tank to provide the oxygen. Cause bubble design offers the highest oxygen transfer efficiency in MBBR process, and it is simple reliable system with no moving and electrical parts in the tank. The header and lateral type air grid is placed at the bottom of the tank, and hole will face the bottom of the tank so that air first strike the flow and then rise upwards. It avoids creation of any black pockets in the reactor and settling of sludge. Then comes the stage 12. To recirculate residual biomass with sewage into the anoxic tank, the pumps are provided which takes sewage from the bottom of MBBR2 where outlet riser screen is placed. Centrifugal pump are provided for the purpose. Stage 13. Settling. It is necessary to separate the decomposed sludge from the treated sewage before any further treatment. For the purpose, high settling rate tube settler is provided. Sludge be drained to sludge sump through electrical equated valve. Then the stage 14. Chlorination. The treated sewage is collected in the chlorination tank and disinfected through hypo. HDPE tank from hypo solution and its dosing pump is provided for the purpose. Chlorine being a very strong oxidizing agent, a small dose is enough to achieve desired level of disinfection. Stage 15. Tertiary treatment. From the chlorination tank, treated sewage is pumped through centrifugal pump to the tertiary treatment unit. Tertiary treatment unit comprises of dual media filter and activated carbon filter. Then stage 16. Sludge handling. Sludge produced in the system will be transferred to the sludge holding tank from the bottom of the tube settler through pump. Sludge is pumped to screw press sludge dehydrator for dewatering. Polyelectrolyte is dosed to enhance the dewatering efficiency. Sludge feed pump. Centrifugal monoblock self-priming sludge pumps shall be used for pumping sludge to unit. The pump shall be designed to operate satisfactorily without detrimental surges, vibration, noise or dynamic imbalance. Sludge dewatering unit. The multi-disc screw dehydrator machine is used for dewatering for sludge. The cake produced by multi-disc screw press dehydrator can reach dry solids content as high as 18 to 25% with biological sludge. The STP parameters achieved are pH in raw sludge characteristics, which is 6.5 to 8.5. The parameter treated by sludge. After the sludge sewage treated, the parameter should be 5.5 to 9.0. The value of TSS of raw sludge is 300 mg per liter. It should be less than 20 mg per liter. The value of biological oxygen demand at 20 degrees Celsius is 275 mg per liter for raw sewage, which is supposed to be less than 10 mg per liter. The chemical oxygen demand, which is 600 mg per liter of raw sewage, supposed to be less than 50 mg per liter. Oil and grease for raw sewage is 10 to 20 mg per liter, which should be less than 10 mg per liter. FCMPN is very high for the raw sewage, which is supposed to be less than 100 ml. Dissolved oxygen, which is nil for raw sewage, supposed to be 2 mg per liter or more. residual chlorine, which is nil, is supposed to be more than 1 mg per liter. Total nitrogen, 50 mg per liter for raw sewage, supposed to be less than equal to 10 mg per liter. As per the MES policy of April 2020, referred NGT orders. These points we have already covered above. Now let's talk about MBBR technology. Biological decomposition, moving bed bioreactor. The main pollutants in the raw sewage are represented in the form of biochemical oxygen demand and chemical oxygen demand. The ammoniacal nitrogen, nitrate nitrogen and phosphorus present also represent as polluting substances. The bacterial ability to synthesize the organic matter to harmless end product like carbon dioxide and water molecules is utilized to treat the raw sewage. The large surface area of the plastic provides abundant surface for bacterial growth. Biomass grows on the surface as a thin film whose thickness usually varies between 50 to 30 micron. Each individual biocarrier increases productivity through providing protected surface area to support the growth of heterotrophic and autotrophic bacteria within the cell. It is the high density population of bacteria that achieves high rate biodegradation within the system, while also offering process reliability and ease of operation. The bacterial layer growth on the media surface increases to a certain extent and then get sloughed off after a specific period. This phenomena is called sloughing. This creates new surface for further bacterial growth. Sloughing takes place only after complete growth and subsequent dying of the bacterial layer, and hence the slough of material is completely digested. Wastewater enters the moving bed biofilm reactor MBBR, where the biomass attached to the surface of the media degraded organic matter, resulting in BOD removal and or nitrification depending on the type and characteristic of the wastewater. MBBR media, a special plastic carrier that provides a surface where a biofilm can grow. The carrier are made of a material with a density close to the density of water, 1 gram per centimeter cube. That is polypropylene, which has a density close to 0.95 gram per centimeter cube. The carrier will be mixed in the tank by the aeration system and thus will have good contact between the substrate in the influent wastewater and the biomass of the carriers. For long life media, the material should be virgin and the media color should be translucent. Jai Hind, thank you.